All right, here we're looking at formative assignment number 1 from Unit 4, which is on polynomials. And your basic idea here is you're just putting these in order and naming these. So the first couple are very straightforward. You're just going to put them in order and name them from the list of, either constant, linear, quadratic, cubic, and then the number of terms is either monomial, binomial, trinomial, or quadnomial. Down here, you get into a little bit of interesting things. Let's zoom in and take a look. So on this first one, even though you have fractional coefficients, the exponents are how you organize it, making this first, this second, this third, and that would be a quintic trinomial, even though you have fractional coefficients. I always like to mention the fact that when you have a line, for basically most of your Algebra 1 school year, you're graphing things like y equals 1/2 x plus 3, and that is a linear binomial. So that's not a problem. The problem exists when you put it in the exponents. You might remember from chapter 2 that these are square roots and fourth roots, so that's not a polynomial, it's actually called a radical. Over here, we have this fun one over here. What do you do when there's no variable? That's called constant. One term is monomial, so constant monomial. All right, from there, we start talking about problems where we need to understand the difference between subtraction and multiplication, right? So in this problem, we're just subtracting, so we distribute our negative sign, then we combine like terms, but be careful. You don't want to put this fourth power term first. You actually want to put your sixth power term first, right? So you're going to be adding negative 5x to the sixth and negative 5x to the sixth as your first thing you have. Then you'll have 3x to the fourth plus 7x to the fourth, which makes 10x to the fourth, and then the cubes also combine. You don't need to name this or factor this. You're just simplifying. Simplifying does not means that you do not factor. Factoring is for division or solving. So the next one's very similar. It's a very similar problem. And then number 9, we're doing multiplication of larger things. So you just, you put this in the top, and then maybe you put this one in the row here, right? And then you just start multiplying things together, and your like terms will be on the diagonals. Now I want you to try that one, but I did do number 12 all the way out. Notice I put this one going this way and this going that way. You could have done it the other way. I just did it so it fit in my box. If you wanted to put this one going across and this one going down, it doesn't really matter. Your answers will still be on the diagonals, and this is the answer that I got after I multiplied everything out. Now, number 11 is interesting because there are 3 of them. So it's very important to understand that this 3 right here actually means that you then have 3 things. So I multiplied the first 2 out first, and my answer, of course, was on this diagonal, right? So my like terms. And the 4x squared minus 12x plus 9 ended up going on a new box that you will then multiply with 2x minus 3. So fill in that box, and your answer to the second box will actually be the answer. Now, when you do division, you will get the same answer twice. It is intended that you'll get the same answer both times. Okay. And so notice that I did that here. I got the same answer for those. Long division takes a little longer. Synthetic division is a little faster. Let me actually do one that has a little bit more interesting things going on to teach you something very important about long division. And that is, why don't we do number 18 together? Okay, so if we take a look at 18, most students like to do the long division portion first. I'm sorry, the synthetic division portion first, just because it's a whole lot easier in terms of the amount of thinking and algebraic skills required. But there is something interesting that'll happen in this problem. First thing I like to do, and this is just a Mr. King thing, is I like to label the columns with the exponent portion before I then put in the coefficients. That way you can just kind of keep track of what's happening. That is a 3, that is a -5, this has a 2, this has a 3, this has a -2. And then we have to find the root for synthetic. So to find the root, we would add 2 and then divide by 3. And so x equals 2/3, and that's what goes right here, positive 2/3. So inside here you add, so 3 plus nothing, or just draw an arrow, you get 3. And then what it's very important to understand, okay, is that when you take this 2/3 here and you multiply it times that 3 that comes there, this seems difficult, but it's not, right? Because it's really just 2/3 times 3. And I've always found it interesting, this number of students that don't know that you can just cross those out, right? That's a thing, that's legitimate. And so when you take 2/3 and multiply times 3, you just get 2. And so when you do this problem, it actually ends up being pretty reasonable. So let's knock this out. This will be -3, and then I multiply by 2/3, and that will give me -2. That gives me 0. I multiply by 2/3, that gives me 0 again. I get 3. I multiply by 2/3, and I get +2, right? 2/3 times 3 is 2, and then I add that, and I get 0. So my answer is right there, and the answer you get is 3. Remember, this will reduce by 1, so this is a fourth, this will be a third, this is a third, this will be a square, this is a square, this will be an x, this is an x, this will be a constant, this is a constant, and it'll be a remainder. And so the answer you get is sort of weird because it's actually not correct, and I'm going to show you why when we do the long division. You end up getting 3x cubed plus negative, oops, sorry, let me make that -3x, right? You're just doing these coefficients. So -3x squared is this one, and then no x, and then +3, and that appears to be your answer. But you see that coefficient? Division doesn't have coefficients. So the actual answer, it's important to remember this. Synthetic division requires you to do this method with this little box, but it also requires you to then divide by the coefficient there on each of the terms. And I'll show you why it doesn't actually emerge as a reason until you look at long division. So we divide all these by the coefficient up here of 3. It's not a GCF, it's actually an error. And the actual answer is x to the third power minus x squared plus 1. Now you might be saying, what just happened? Well, let's take a look at long division. So if I do the same problem with long division, you start to see it at the very beginning of the problem. All right, it's just going to take a second here. All right, so what happens is you can only divide a binomial at a time, right? Binomial goes into a binomial. And so we're going to use, to make this work, we need to turn this number right here. We need to turn this number into this number. So the 3 is good. I didn't need that 3. What I needed was just the x part. So I needed an x to the third, so that when I distributed here, that would give me 3x to the fourth minus 2x cubed. And so when I subtract it here, it cancels out. So I actually didn't need that 3 at all, but there's more to it than that. I'll show you in a minute. So subtract the next term, making an addition. And then that would give me -3x cubed, right? -5 plus 2. Drag this down and then repeat that process. You just have to do it a couple more times. Okay, so I'm trying to make it now become this thing. All right, so let's see, that means I don't need a 3, but I need a negative. And then I need an x squared. As you can see, I'm now getting this answer. I distribute it. So that gives me -3 x to the third power. So -3x to the third power, and then plus 2x squared. And some students will kind of freak out here because you get 0, right? This cancels and this cancels, giving you 0. I need to have a binomial, so I actually would just drag down 2 of these now. So 3x minus 2 is, I drag both those down to maintain this binomial. Okay. And then I do it one more time. You know, I play this game one more time where I need to make 3x become 3x. And that, of course, is just multiply by 1. And so 1 times 3x is 3x. And then 1 times -2 is -2. And then I subtract these and I end up getting 0. So the actual answer you can see is right there. It's x to the third power minus x squared plus 1, which is what I got here. But what is this doing? It's kind of interesting when you see it. It's actually giving you these numbers here are actually the numbers you see here: 3, -3, 0, and 3. So synthetic division doesn't actually give you the answer until you divide by the coefficient. It gives you the middle part of the problem. Now you might be saying, what? Did I do the entire front wrong? Well, on the front, it doesn't matter because your coefficient is 1. So these numbers, x, 5, and 9, match up with 1, 5, and 9, and the remainder, of course, of 20. It all matches up. So you can see that it doesn't actually matter when the coefficient's 1, but when your coefficient is 3, or if it's 2, it does matter. So synthetic division is actually a two-step process of doing the synthetic division and then dividing by the coefficient to make it get rid of these extra numbers that show up along this diagonal in long division. Okay, one last thing is, what about this down here? It's kind of almost a joke, divide each of the following using synthetic or long division, but if you look at these exponents here, they're all bigger than the other problems, right? This is not linear. The definition of synthetic division says you have to divide by a linear binomial. Well, here I have a quadratic trinomial, and here I have a quadratic binomial, and here I have a cubic binomial. You have to use long division. And so, like, if you look at this first one, right? If you look at this first problem, you're just doing long division. You just have to do one thing. You have a trinomial into a trinomial. It takes one step, and then you get a remainder. This one, don't forget to put your 0 in here, and this one's also missing a 0x. And this one is missing a 0x squared, a 0x cubed, a 0x, and a 0x squared. So I wrote that all out for you so you could see it. And it only takes one step as well. You just, once you write it all out with your missing zeros and your missing zeros, you put a 9 here, you distribute that 9x to each one of these, and then you end up getting not enough to do anything with, right? So each of these line up. The only thing you can actually subtract is negative 21 minus 9, which is plus 9. You drag down your 20. How are you going to put a quadnomial into a binomial? You can't. So that's your remainder. But then the next thing is you have a plus minus. Now you can't just take this plus minus right here. You can't just take this and this and say it's minus, because you'll think that that 20 is actually still negative. You have to factor out the negative 1, making it 12x plus 20, then combine those together and get that as your final answer. So just be careful, try not to get too frustrated. In general, it's not too bad, but you want to make sure that you just take your time, make sure things line up, and make sure you understand why sometimes synthetic does not match long. Long is the real answer. Synthetic is a shortcut, so you got to be careful with how that shortcut works. Well, I hope this helps, and thank you for watching.